Okay, so technically I've had one retake of this video. Thing is, first time I was recording this, I didn't have microphone turned on, so now I have to re-record it entirely. Now the problem for me, which is gonna take a little bit of extra time. So the first problem here is expressing the left integral in terms of the right integral. If we were to write it down, you can see that this is easily solved by integration by parts. Let's bring out minus 1/2 here, because if we were to look at e to the power of minus x squared and differentiate it, we'd have minus 2 times x times e to the power of minus x squared. So this is really handy here for this purpose. By the right bracket needs to be an integral. X times minus 2 x times e to the power of minus x squared dx. Cool. Now we can just integrate this by parts. That's gonna be minus 1/2 times x times e to the power of x minus x squared, and we need to subtract the integral of e to the power of minus x squared dx. Okay, cool. I could change the parts of the difference to be swapped so I can get rid of the minus outside. It's basic algebra. I don't want to bother to actually write it down. You get the point. Okay, so now we need to find reduction formulas for these integrals. Let's begin with e. So we need to decrease the power of n, the power of x here, and for that we need to use it as u in integration by parts. That will allow us to decrease this power. So let's take x to the power of n as u, and naturally for v we would have to take e to the power of x. So this is going to be equal to x to the power of n times e to the power of x minus n times the integral of x times n minus 1 times e to the power of x dx. Cool. We still have this integral over here that we need a reduction formula for. For reference, this is natural logarithm. That's just the way the notation in some branches of mathematics is. This is not common logarithm. So I'll write it as ln purely because it's easier to write. I don't want to bother to write extra letters. So here for u we're gonna pick natural logarithm of x raised to the power of n, and for v we're gonna pick x. So x times natural log of x to the power of n minus the integral. Let's bring out the n instantly right away, yeah? So the derivative of ln x to the power of n with respect to x is going to be ln x to the power of n minus 1 over x. And x over x is going to be just 1. So we're going to have the natural logarithm raised to the power of n minus 1 left. Integrated with respect to x. I forgot to mention the n here because I have already included it. That's part of the derivative too. Okay, cool. We have found the reduction formula for this integral. So yeah, that's it for today. Took a few retakes because I'm silly. So bye.